morning, girls. Today is the continuation of previous class. We know previous class we done the classification of matter, physical and chemical properties of matter, etc. Today is units and measurement. All of you know unit. For what we are using unit. Okay, unit we are using to measure a particular quantity. Generally, we can say a physical quantity. Okay, so unit means it is a definite, it is the magnitude of a, it is a definite magnitude of a physical quantity accepted all the standards to measure that physical quantity. Nothing is there. What is that? It is a definite magnitude of a physical quantity. It is a magnitude of a physical quantity. Okay, and it is accepted by all the standard to measure a physical quantity, or we can say simple way, it is the definite magnitude of a physical quantity. Okay, it is a definite magnitude of a physical quantity, that is known as which one? The units. Previous olden time, two types of units were used, that is English system of units and metric system of unit. What is it? English system of units and metric system of units. Okay, but and these two systems were used in the different parts of the world in the olden time. But after that, in around 1960s and all scientists started to thinking about a common common standard units to represent the physical quantities, and they named it as International System of Units. That means it is accepted all over the world. That means only one common system now it is there. Okay, that is International System of Units, and it is represented by SI. What is it? International System of Units. That means it is accepted all over the world. Okay, so in SI system or International Standard System, there are 7 basic units are there. Okay, so it is given, it is important. 1 mark question you can expect from here. Okay, so first one is mass. What is the physical quantity? Mass. Its name of its units according to the International System of Unit. What is the name of this unit? All of you know, that is kilogram. Okay, and what is the symbol? How we can represent the kilogram? It is kg. Small letter K, small letter G. Okay. Then next physical quantity is length. Length, the name of unit is meter. Okay, so how we can write meter? Small m. Okay. Next one is time. Time, second, and it's small s. Next is temperature. Temperature, it is degree Celsius is there, Fahrenheit is there, but Kelvin is the international system, the common system. Okay, according to SI system, what is the name of the unit? Temperature, Kelvin, and it is represented by which one? Capital K, not small k, capital K. Okay. Next is electric current. It is ampere. What is the name of the unit? Ampere, and it is represented using capital A. Next is luminous intensity, and we don't want all the terms and all. Okay, these electric current, it will come in physics. In our syllabus it is not required. We want only the name of unit and its representation. Candela and CD, capital C and small d. Last one is amount of substance, and it is the name of unit is mole, and it is represented as MOL. Mole, MOLE, and here it is represented as MOL. So these are the 7 basic units used according to which one? SI system. So they will ask, what is the unit of SI unit of candela? So name of the unit you have to write candela. What is the SI unit of luminous intensity? So you have to write name is candela and is represented by CD. Okay, so that is the, so in the olden time 2 system of units were used. Which one? English system and metric system. Okay, later that it is in around 1960s there is a common units for measurement, common units of measurement. Okay, that was which one? International System of Units or SI system, and it is having how many 7 basic systems are there for the measurement, that is mass, length, time, temperature, electric current, luminous intensity, and amount of substance. So clear all of you these 7 basic units according to which one? International System of Units. Definitions for name of the units like meter, kilogram, etc., luminous intensity, that everything, candela, ampere, etc., is given in the note. Okay, so you can read that one. It is no need of by hearting the definitions for the SI units. Okay, only you have to know the SI name of the SI units and the quantity, physical quantity, its name and name of the unit and its representation, that means symbol, how it is written. Okay, next we are moving to the prefixes using in SI system. Okay, so to represent the small and large quantities, physical quantities, SI system is using some prefixes. All of you know that, I think 10 raised to minus 9 we are using as nano, like. Okay, so these are the general prefix using by SI system. This is also no need of by hearting. This will be mainly useful for doing the problems. Okay, so first is multiple. So it is to express the large quantities we are using multiple, and for expressing smaller quantities we are using multiples. That means 10 raised to minus 1, 10 raised to minus 2, that is small quantity. 10 raised to 2, 10 raised to 3, etc. large. So we are using it a multiple prefixes. But in case of small quantities we are using a sub-multiple prefix. Okay, so first is 10 raised to 1. What is the prefix term you are using? Deca, and it is represented by the symbol DA. Next is 10 square. It is hecto, and we are using a symbol H. Okay. Then 10 raised to 3. It is kilo. Okay. And we are using K. Then 10 raised to 6. We are using mega, capital M. Okay. Here also capital K. 10 raised to 9. It is giga, then G. Then 10 raised to 12, it is tetra, capital T. 10 raised to 15, it is penta, capital P. 10 raised to 18, exa, capital E. 10 raised to 21, zeta, Z. 10 raised to 24, iota, Y. Iota, Y. Okay. So no need of by hearting. Okay. 10 raised to minus 1. It is a small quantity. That is why we are using sub-multiple here. Okay. Deci. What is the prefix? Deci, and the symbol is small t. 10 raised to minus 2, centi, C. 10 raised to minus 3, milli, M. You know milli and all, no? 10 raised to minus 6, micro, mu. 10 raised to minus 9, nano. Commonly we will use this nano in, problems. Okay. Then 10 raised to minus 12 equal to pico, that is P. 10 raised to minus 15 is equal to femto, F. Small n, P, F. Okay. 10 raised to minus 18 is equal to atto, A. 10 raised to minus 21 equal to septo, Z. 10 raised to minus 24 equal to yocto and Y. This is small letters. Okay. Here it is capital letters. Okay. So these are the prefix to convert. We will, in problems we will use. So that time I will tell you how and all it is useful in problems. Okay. Then next is mass and weight. These are the prefixes. Okay. Not the by hearting. Next is mass and weight. Okay. What is mass? Mass means it is the amount of matter present in a substance is known as what? Mass. Mass means what? It is the amount of substance present in a amount of matter present in a substance is known as what? Mass. But weight means what? It is a force exerted by gravity on a substance. So what is a weight? It is a force exerted by gravity. All of you know gravity force is there. So it is a force exerted by gravity on an object or on a substance is known as what? Weight. Okay. So mass is constant. Mass is constant because it is depending upon the amount of matter present in a substance. Right, but weight is not constant because it is depending upon the gravitational force. We know gravitational force is different in different places. Okay, so with change in the gravitational force, what will be also change? Weight will be also change. Okay, so what is the difference? Main difference between mass and weight. Mass is constant, but weight is not constant. It will vary from one place to another place. So that is mass and weight. Mass means it is the amount of matter present in a substance. Weight means what? It is a force exerted by the gravity on an object or a substance. Clear? Next is volume. All of you know what is volume. Volume of a cube means how we will write a cube, right? Okay. So Volume means it is length cube. SI unit you have to know. They will ask, okay, length cube. Volume means, we know volume means what? Height into breadth into length. Length into height into breadth, okay. So, for example, for a cube, if one side A means what is the volume of that cube? A cube we are speaking. So, volume equal to length cube. We know what is the SI unit of volume. You have to know. They will ask, okay. So, we know for length we are using M. Okay, so volume means length cube. So we are using meter cube. So what is the SI unit of volume? It is meter cube. SI unit means you have to write meter cube. Okay. Then for representing small length and all, we can use with one centimeter cube, or you can use decimeter cube. We can use centimeter cube, or which one? Decimeter cube. Okay. So all of you know 1 liter equal to how much milliliter? 1000 milliliter, right? That is equal to 1000 cm cube. That is equal to 1 dm cube. Okay, so here you have to know, the important thing is you have to know the SI unit of volume. What is SI unit of volume? Meter cube. Next is density. Density of a substance equal to mass per volume. Okay, so what is density? Density equal to mass per unit volume or mass per volume. So this is also important. They will ask the SI unit for which one? Density. So what is SI unit of density? Mass. We know mass means what? Kilogram. In 7 basic SI system, according to SI system, what is the unit of mass? It is kilogram. So how we will represent it? Kg divided by volume. Volume, just now I wrote what is SI unit of volume? Meter cube. Okay, so that is kilogram per meter cube. Okay, that's can I write it as kilogram m raised to -3. If you are writing kilogram per meter cube, also not a problem, or kilogram per meter cube also you can write. Otherwise you can write kilogram per meter cube. So any one you can write for the SI unit of which one? Our density. So density equal to mass by volume. So what is the SI unit for density? Density kilogram per meter cube. You can write like this, or you can write like this, or you can write like this. Okay. Anyway, you can write it. Okay. So volume means it is meter cube, and density means what? Kilogram per meter cube. So here, volume, SI unit of volume and SI unit of density is very important. Clear all of you about the SI unit of volume and SI unit of density. Next is temperature. What is temperature? Temperature means it is a physical quantity used to measure the hotness and coldness of a substance, or it is a physical quantity of a matter used to measure perceptions of hot and cold. Okay, so that is known as what? Temperature. What is, we know the temperature, its SI unit is which one? Kelvin. Kelvin, and it is represented using capital letter K. There are 3 scales are used to represent the temperature. Okay, all of you know that degree Celsius scale is there, Fahrenheit scale is there, then our Kelvin scale is there. Kelvin is the SI unit of temperature. Right. So degree Celsius scale means it is a scale in which the boiling point, freezing point of the water is 0 degrees Celsius, and the melting point of water is 100 degrees Celsius. That scale is known as what? Degree Celsius scale. So what is a degree Celsius scale? Degree Celsius scale means it's a scale in which it is taken 0 degrees Celsius as the freezing point of water, and the boiling point of the water is which one? 100 degrees Celsius. All of you know what is the freezing point of water? 0 degrees Celsius it will freeze, and what is the boiling point of water? 100 degrees Celsius. That means at 100 degrees Celsius water will boil. Okay, so that scale that gives the scale that giving the 0 degrees Celsius is stay as the freezing point of water, and 100 degrees Celsius as the boiling point of water is known as which one? Degree Celsius scale. Then which one? Degree Fahrenheit. Degree Fahrenheit, it is a scale of temperature that consider the 32 degree Fahrenheit as the freezing point of water and 212 degree Fahrenheit as the boiling point of water is known as which one degree Fahrenheit. Okay. Then Kelvin scale. Kelvin scale means it is in Kelvin scale the lowest temperature is 0 Kelvin. Okay, and it is also known as the absolute scale. Okay, so it is the Kelvin scale. It is the lowest temperature is 0 Kelvin, and it is considered the boiling point of the water as 373. 0.145 Kelvin. We can approximately take it as 373 Kelvin. No need of writing 15. Okay. And the freezing point is which one? 273.15 Kelvin. Okay. So in Kelvin scale, it is considered the boiling point of water as 373 Kelvin and the freezing point of water is which one? 273 Kelvin, and the lowest temperature is which one? 0 Kelvin, and it is also known as absolute scale of temperature. So there are three scale of temperature is there: degree Celsius scale, Fahrenheit scale and Kelvin scale. So in degree Celsius, what is the freezing point of water? It is 0 degree Celsius and the boiling point is 100 degree Celsius. In Fahrenheit scale, the freezing point of the water is 32 degree Fahrenheit and the boiling point is 212 degree Fahrenheit. In Kelvin scale, what is the freezing point of water? It is 273 Kelvin and the boiling point is 373 Kelvin. Okay, it is also known as absolute scale. Then how we can convert the degree Celsius to Fahrenheit? We have to know how we can convert the degree Celsius to Fahrenheit and degree Celsius to Kelvin, etc. So here there is a relationship to calculate. There is a relationship between Fahrenheit scale and degree Celsius scale. Okay. So first degree Fahrenheit, 0 degree Celsius to Fahrenheit. How we can convert degree Celsius to Fahrenheit? So the relation is written here. Degree Fahrenheit equal to 9 by 5 into degree Celsius plus 32. So what is the degree Fahrenheit equal to 9 by 5 into degree Celsius plus 32. Or degree Celsius, if it is given degree Celsius, how we can convert into Fahrenheit? That just rearranging this equation, degree Celsius equal to degree Fahrenheit minus 32 into 5 by 9. Okay. So for example, one problem, two problems we will do here. Convert 37 degrees Celsius into Fahrenheit. 37 degrees Celsius is given. Okay. We have to convert that into how much? Fahrenheit. We have to know 37 degrees Celsius means how much Fahrenheit. Okay. So we know to convert the into Fahrenheit, the degree Celsius into Fahrenheit. What is the degree Celsius into Fahrenheit? The equation is here. Fahrenheit equal to 9 by 5 into degree Celsius plus 32. So we will apply in that equation. So degree Fahrenheit equal to 9 by 5 into how much is the degree Celsius temperature is given in the question? It is 37 degree. So 37 plus 32. So after doing calculation, we will get 98.6 Fahrenheit. So 37 degrees Celsius means what is the temperature in Fahrenheit? It is 98.7 degree Fahrenheit. All of you know what is the human body temperature? It is 37 degrees Celsius. That means it is in thermometer 98.6 degree Fahrenheit. If it is means normal temperature, more than this means what is that? Fever. Okay. Next is convert 100 degree Fahrenheit to degree Celsius. Here it was what? Degree Celsius. Degree Celsius was given, we have to convert to Fahrenheit. Here it is Fahrenheit temperature is given, you have to convert it to degree Celsius. So the equation it is here it is there. Degree Celsius equal to degree Fahrenheit minus 32 into 5 by 9. Very easy direct substitution. So degree Celsius equal to what is the Fahrenheit temperature given in the question? 100. 100 minus 32 into 5 by 9, and after calculation we will get 37.7 degree Celsius. So these two relations, this only one relation is required. Just rearranging that relation, we will get the second one. So degree Celsius to Fahrenheit is this one. Fahrenheit to which one? Degree Celsius to Fahrenheit is this one, and Fahrenheit to degree Celsius is second one. Okay, so this is first question, 37 degrees Celsius to Fahrenheit. Clear? Okay, so that is which one? The Fahrenheit and relationship between Fahrenheit and degree Celsius. Next is the relationship between degree Celsius and Kelvin scale. Degree Celsius and Kelvin scale, I think all of you know that how we can convert the degree Celsius into Kelvin temperature. Okay, how we can convert degree Celsius equal to degree Celsius equal to how much? Kelvin. Kelvin equal to degree Celsius plus 273.15 Kelvin was there. Okay, no need of writing 15 Kelvin. Approximately we can take what? 273 Kelvin. Okay, so given degree Celsius, how we can convert into Kelvin scale? Just we have to add 273 with the degree Celsius temperature. For example, 27 degrees Celsius means how much it is in Kelvin scale. Convert 27 degrees Celsius to Kelvin scale. So what is the answer? We know Kelvin equal to degree Celsius 27 plus 273. 27 plus 273. So what is the answer here? 300 Kelvin. Right. Okay. So converting the given degree Celsius into Kelvin scale means just you have to add 273 Kelvin. But how we can convert the Kelvin scale into degree Celsius? Kelvin scale into degree Celsius means just you have to subtract which one? The Kelvin scale. Okay. So degree Celsius to Kelvin means plus 273. Degree Celsius to Kelvin means plus 273. Kelvin to degree Celsius means what? You have to just subtract the 273. Then we will get which one? The degree Celsius value. For example, it is given 373 Kelvin. Okay, so how we can convert this one into degree Celsius? Into degree Celsius means I already told you what? 373 minus which one? Degree Celsius means 273. We have to subtract then 100 degrees Celsius. Okay, so conversion to degree Celsius to Kelvin means just the given temperature, how much it is given, just we have to add with 273, then we will get it Kelvin. Then the given Kelvin temperature, how we can convert to degree Celsius, just subtract 273 from the given Kelvin value, Kelvin temperature, just subtract the 273 Kelvin, then we will get the temperature in degree Celsius. Okay, so Kelvin scale equal to what? Degree Celsius plus 273. Okay, or Kelvin scale equal to degree Celsius to 273 Kelvin. Okay, so given temperature in degree Celsius plus 273, we will get which one? Kelvin scale temperature. Clear? So I will draw the boiling point, freezing point, then human body temperature, etc. in a scale, 3 scales together I will draw here. Okay, first this one, this is in degree Fahrenheit scale. Okay, then second one is in degree Celsius. Okay, then third one is in which one? Kelvin scale. 3 scales are I wrote. Okay, so we know first is writing the freezing point of water. Freezing point of water. How we can write in 3 units freezing point of water? All of you know what is the freezing point of water in degree Celsius? It is in 0. Right. Okay. Then what is the value in Fahrenheit? That is the 32 Fahrenheit. Degree Fahrenheit. Okay. Then what is the value in Kelvin? We know 0 degree Celsius. Converting to Kelvin, what we have to add? Plus 273. Same 273 in Kelvin scale. 273 Kelvin. So this is in degree Celsius. This is in Fahrenheit, and this is in Kelvin scale. Which one? The freezing point of water. Then boiling point. FP means freezing point. Okay. Boiling point of water means how we will write. All of you know what is the boiling point in degree Celsius? 100 degrees Celsius. Right. Okay. In Fahrenheit it was given 201 to 212 degree Fahrenheit. Right. Then in Kelvin scale, I already told you converting the degree Celsius into Kelvin means how much we have to add? 273. So what is that? 373 Kelvin. 373 Kelvin. Then what is the body temperature? Body temperature in 3 units, how we can write? How we can write? We know what is our human body temperature, 37 degrees Celsius. I converted in that problem using that equation and it is found to be in Fahrenheit 98.6 degree Fahrenheit. 98.6, that is the normal human body temperature in Fahrenheit. Okay. Then converting this degree Celsius into 273 means how much we have to add? 337 plus 273. 37 plus 273 means how much it is? 300. So that is it, 300 Kelvin. That is it, 300 Kelvin. Okay. So that is which one? The freezing point of water, boiling point of water and the body temperature in 3 different scales I wrote. Clear all of you? Next term is scientific notation. Okay, scientific notation means to write large numbers. It is very difficult to write the large numbers. Okay, for example, 65, 0, 0, 0, 0, 0, 0, 0, like that. Means it is very difficult to write. To express that type of big numbers, we are using one notation that is known as scientific notation or exponential notation. Okay, all of you know that, but the term is new, scientific notation or exponential notation. So in this type of notation, we are and how we can represent a number in this notation, n into 10 raised to n. Okay, here capital N equal to the digit term and it varies between 1 to 10. Okay, into 10 raised to small n equal to exponent term. It may be positive or negative. Okay, so n into 10 raised to n equal to digit term and small n equal to exponent term. For example, how we can write this one? 232.508. Okay, so you all of you know, so we can write this as 2 point in, like n should be in between 1 to 10. No, 2.32508 into 10 raised to 2. How it is 10 raised to 2? Because the point was here, I shifted the point here, right? So to move to right 2 digits, so we have to multiply with 10 square. All of you know how to do this one. Okay, then 65, this number 650000. So how I can write using the exponent? 6 is taking as the capital N, so 6. Okay, then 0.5. Okay, so 0.5. Then these zeros we can write it as 10 raised to 5 because it is from here. I am putting 5 here, point here. So 1, 2, 3, 4, 5. 5 digits we have to move to right side. So we have to multiply with what? 10 raised to 5. If 4 digit you have to multiply to right means you have to multiply with 4. But 4 digit if you have to go to left means what you have to do? You have to multiply with the -4. You know that division by 110. Moving forward means right means multiplication with the 10. Moving left means what? Division by 10. Some problems based on multiplication and division based on this scientific notation we can do. For example, it is given. You can see here 5, 6, 1, 2, 3, 4, 5, 6, 0, 0, 0, 0. Okay. This number is 69, 0, 0, 0, 0, 0. It is not easy to simply multiply. So using scientific notation, first we can write this one. 56, 0, 0, 0, 0. We can write it as 5.6 into 10 raised to 5. Getting what I am telling here. It is point I put here. So we have to move 1, 2, 3, 4, 5 digits to right. So it is 10 raised to 5. Okay. Here I am writing 6.9. Okay. Then 1, 2, 3, 4, 5, 6, 7, 8 digits we have to move right. So 10 raised to 8. Okay. So after writing that, we can take which one? That means 5.6 into 10 raised to 5 into 6.9 into 10 raised to 8. So we will multiply these terms, n terms. Okay. Capital N terms. That is 5.6 into 6.9. Okay. Into common we can take 10 raised to, because multiplication means we can take it as which one? Addition. Okay. So 5 plus 8. Exponents 5 here and 8 here. So 10 raised to 5 plus 8. So after solving this one we will get 38.514. 5 plus 8 means what? 10 raised to 1. 30. Okay. So just write in scientific notation, then do the multiplication for that terms, then add the exponents. So that is multiplication. One more example. Division 0.0027 divided by 55000. Okay. So how we can do? First we have to write this one in which one exponent 10. So I am writing as 2.7. We have to write n in between 1 to 10 now. So 2.7. Okay, 2.7. So we know how, here I am putting point here. So from here 1, 2, 3 digit. What we have to left it is should move. Okay, here it was what? Right it was zeros. Here it is the left. So we have to put 10 raised to minus 3. Okay, then second number is 55000. So how I can write 5.5 into 10 raised to 4. Clear? So division 2.7 divided by 5.5. These numbers we have to do the division. And here the exponents 10 raised to minus 3. Then this 4, it is plus 4, it will go up means it will become minus 4. So we will get 10 raised to minus 7. And after calculation, the answer is found to be 0.4. You can do the calculation using calculator. You can check the answer. Okay. The answer is 0.4909 into 10 raised to minus 7. After doing the calculations of this problem, we will get 0.490 into 10 raised to minus 7. So, in multiplication and division, what you have to do? First, the given number, you have to write in exponent. Then, do the division or multiplication for the given number. Then, add or subtract according to the exponent's sign. Okay. So, that is the addition and multiplication based on which one? The scientific notation. Clear all of you? This is the addition and subtraction based on which one? Scientific notation. Okay. In addition and subtraction, not like division and multiplication, directly we can do. Here, in the given numbers, we have to make the exponents equal first. Exponents same first, then we can do the subtraction or addition. Okay, so first thing is we have to make the exponents of the numbers same. Okay, for example here 6.65 into 10 raised to 4 plus 8.95 into 10 raised to 3. Here you can see the first term the exponent is 4 and the second term the exponent is 3. So we have to first make these terms equal or same. Okay, so either 4 or either 3, any one you can select. I am selecting 4 as the common. Okay, so first 6.65 into 10 raised to 4. Okay, but this number also we have to convert the 3 exponent into 4. Okay, so how we can write 8.95 into 10 raised to 3? Can I write it as 895 into 10 raised to 4? Right, because we are moving one term digit, this one point, decimal point to this side means we have to multiply with the 4. Then only we will get 8.95. Okay. So I made these two things equal exponents. Then 6.65 plus 0.895 into common exponent term. Okay. So we will get after solving 7.54 into 10 raised to 4. Okay. Next problem here you can see 2.5 into 10 raised to minus 2 minus 4.8 into 10 raised to minus 3. Here the exponents is minus 2 and minus 3. So what you have to do? You have to make it common or same. Okay. So I am making it as a minus 2 as the same. So first term 2.5 into 10 raised to minus 2 minus 0.4. How I can convert 4.8 into 10 raised to minus 3? I am converting to minus 2. Minus 2 means what? 0.48 into 10 raised to minus 2. Okay. Then only if you are multiplying, we will get which one? 4.8. 4.8 into 10 raised to minus 3. Okay. So that means 4.48 into 10 raised to minus 2, we will get 4.8. Okay. So then 2.5 minus 0.48 into common exponent 10 raised to minus 2. After doing the calculations, you will get 2.02 into 10 raised to minus 2. So you have to keep in mind to convert or to move a decimal point to right. To right means what we have to do? We have to multiply with the positive exponents. For example, we have to two decimal point we have to convert to right means 10 square. If you have to move 2 decimal point to left means 10 raised to minus 2, like that. All of you know that, right? No? Okay, so this is the scientific notation based on which one? Addition and subtraction. So today's class just summary of the today's class we done. What are the things we done? We will see. We will check once again. Okay. So first we started with which one? The units and measurements. 7 SI units were there. Then prefix were there. Then the SI unit for volume, density, then temperature, different scales for representing the temperature. Then the last was this one, which one? Scientific notation. So hope all of you understood today's class. Thank you, girls.